look at, guys, today the notes for 10.3. Okay? 10.2, if you don't remember, was all about, 10.1 was all about square roots and how the function, the graph moves. And 10.3 was all about cube roots. And then we're going to look at 10.3 is kind of everything. It's all kinds of different things that we can look at. So the first thing we're going to do is I'm going to use two different colors. You guys, I suggest that you do, or you label your graph really well so you see the difference. I'm going to graph these two tables. At x, -2, I'm going to go to 1. At -1, I'm going to go to 4. 0, 5, 1, 4, and 2, 1. Okay, this is the one that says analyze function graphically 10.3. It does not say anything about classwork on it. That helps. Okay, so this graph is most likely what? Is it a cube root, a square root, a quadratic, so something squared? Is it what kind? Is it an absolute value? What kind of function is it? Your phones should not be out, guys. You should be doing this. What do we think this is? It's a parabola, so it's squared, okay? But instead of at 0, 0, it's moved up 5, so that's
Did you say a
parabola. Quadratic, x squared. It always concerns me when you ask questions like that, Caleb, but I'm glad you do. A parabola is x squared. So this is x plus 5 squared. Negative x plus 5 squared. Okay? It's upside down, so we flipped it over. And it's moved up 5. So, if you look at me standing in front of the room with my arms in the air, this is x squared, right?
Yes.
Okay? We put a negative in front of it, I flip it over. Okay? If it's plus 5, I move up 5. Is that 5 in the right space?
Yes.
No.
What? What do you mean no?
It's not in the right space.
It says 5 right there.
Yeah, that I just wrote it down. It's not right. Because it's y minus x squared
Oh, I thought you were talking about the graph.
plus 5, right? That would be the correct way to make it. Because, yes, because it is on the outside, and the outside moves things up or down. Inside, next to the x, moves things right or left. Right? Okay. Let's look at the second one.
It's plus 5.
At
because it's
negative-
5, right?
Because it's moved up 5, yeah. -2, 2. -1, 1. 0, 0. 1, 1. 2, 2. What does that look like? In green. It does look like absolute value. I think it's just absolute value of x.
Oh, then it's because it's a V shape.
Because it's that V shape, right?
What is that?
Absolute value of x, like this.
Oh, I couldn't read it.
Is
Sorry,
this type
I'm
of
green.
stuff going to be on our quiz tomorrow?
All right.
Are you serious?
So, instead of complaining, you guys need to listen. I know that's hard. Okay. Let's look at, let's actually skip this one right here. We're going to move all the way down. We're going to use our graphing calculator for the next 3 graphs. Okay, you guys seem to like that better. So I'm going to pull up my graphing calculator, and I'm going to put in there, open a graph page, and if the F1 x doesn't show up, if you hit the tab key, it does. And then I'm going to put negative x squared plus 2. See my parabola? Okay. So I know I went up 2, and it's negative. Right?
It's positive be facing up.
What is the domain? What are the possible x's for this?
X is
Is there anything that it can't be? Look at the x-axis. Is there anything that you think it couldn't be?
Anything that, or
No, it's all real.
What?
All real numbers.
How do you know that?
Because if you look, your thing keeps getting wider and wider and wider. The more you go, the more it will be there. There's nothing it says like can't be this. It doesn't stop somewhere. Yes.
Oh, like the only way that would be is if it was straight.
So I'll show you ones where we will have something for domain, but this would be one. Now here's my other question. Look at this. What y's are not covered? What range?
Anything
So y has to be less than or equal to 2.
because it's facing downwards and everything's upwards, so it has to.
So everything up here we're not covered in our graph.
Two up, so it can't be 3, 4, 5.
Right. Okay, let's turn the page. Okay. Anybody know how to put absolute value in these calculators? Yeah, Grace?
How do you figure your graph?
So I thought you, okay. Anyways, absolute value of negative 2. We know absolute value means it goes straight up and down. And we're going to go down 2. So we have the absolute value looks like this, right? That's straight V. Correct? Okay. What is the domain? I don't know. All real numbers. This was the last section that Miss Rowe taught you, so I don't remember how to do absolute value.
Y is greater than or equal to.
Yeah, we don't remember that.
Okay? So y is greater than or equal to negative 2. That's my range. What is it? Ah, okay. So let me show you guys how to do this. You hit this little button right here, and a bunch of things pop up. And it's this one right here with the 2 lines straight up and down. I looked for it earlier, I couldn't find it. Absolute value of x, move it to the outside, oops, minus 2. There you go. Good job, Indy. I don't know if we need that.
Yeah.
But we do appreciate India. Yes, yes. You get number 36. Okay. Now, I think there was a typo when this was done, because 2 squared minus 2 is just going to be what? What's 2 times 2? What's 4 minus 2? 2. So 2 is going to be y equals 2. Looks like that, right? So let's do this one. What's the domain for this one? All real numbers.
What number do I
36.
You can just put that 134, right?
How do you know it's on?
34.
Double line.
Oh, so all the numbers were a straight line.
Because the x value could be anything, right? The y is always 2, but the x value could be anything. What does the range have to be? No.
None.
The y value has to be what? 2.
So y equals 2.
That's it. Yes, great.
Because the line is straight, it's never gonna touch X. So how are you gonna know?
Okay, because if I pick a point right here, let's say that's 5. The x value is 5, the y value is 2. If I pick a point right here, let's say negative 70. The x value exists, but the y value is going to be 2. Does that make sense?
Yeah.
The x value can be anything. It's on a straight line. So I'm going to stretch in a straight line as far to infinity and infinity, right? Both negative infinity and positive infinity. So x could be anything. It's y that doesn't change. Okay? It's like you're following an endless road, right? I can pick any point on here, any x value, but y doesn't move. What's confusing, Grace? Right. All the way forever and ever. Do you see that it can be any x value, it just always is 2?
Yeah.
Okay. That's why domain is any number, but y says it can only be 2. Do you get the difference between domain and range? Domain's always the x values, range is always the y.
Okay. Yeah.
Okay. We're going to talk a little bit about minimums, but I'm going to skip down to, no, I'm going to skip down, I might come back to number 1. Let's do 5 first. Okay? Because we just learned about square roots. Before you put this in your calculator, what does that 1 mean? It's going to go to the left 1. What does that 2 mean? It's going to stretch up 2. Okay? So let's put it in our graph. If you hit tab, it'll pop back up.
Oh my God.
We hit 2, square root, x plus 1.
Why is that a 5?
That's just the 5th graph. So we're going to go over 1. And if you hit Control T, you can kind of see that your table at 3, I'm at 4, or when it crosses, when x is 0, y is 2. It goes like this. Okay. So, is there a minimum or maximum for this?
Maximum.
There's a maximum?
No.
None.
What can it not go below?
0.
0. So this is kind of the minimum. Kind of has a minimum, as in 1, 0. Can't go below this point.
Okay, so let me try the next one.
Okay, yeah. Go ahead and try the next one. Try 6. And then we're going to go back and do 1.
3x
Yeah. Why is it 1 0? Why is negative
It should be negative 1, 0. I'm sorry. You're right. Because there's a point where it can't go below. So I kind of think of it as a minimum. It doesn't really look like a parabola minimum. It's kind of different.
Can it be both?
6.
Can it be both?
Cube root. So India or Kevin could show you. 'Cause I think they can both do it.
Oh my gosh.
Control T takes the table off and puts the table on. Okay. So I moved this from here over 1, up 5. Okay. Does it have a minimum or maximum? Could this keep going up, and this keep going down, down? So does it have a minimum or maximum? No. Okay. All right. Let's look at number 1. We've got the absolute value. Can we try sketching this without the graphing calculator? We've got the absolute value. Let's think. This is what I think is going to happen. I'm going to go to the left 1, up 2. So let's put it in our calculator. I think it's going to look like this. Okay? Let me put it in my calculator now. Double check.
Wait, why?
Because this tells me it's inside, tells me it goes to the left. This tells me it goes up. Yep, I was right.
Is it minimum?
It is a minimum. There's a bottom. So my bottom is -1, 2, right? Okay.
So it's a minimum?
Nope.
It's a maximum?
Okay, let's turn it over.
It's maximum.
It's a minimum. It has a bottom, right?
What?
It doesn't have a top where it stops.
It wasn't.
It has a minimum.
Yeah, you just told me it wasn't
Yeah.
minimum.
Can we take it? Can we take it to
It has a minimum. Max, if you ask me that one more time, I'm gonna
So
call
what-
you. I'm just really sick of it. Okay? I'm just like complaining in the middle of what I'm saying.
So would it be,
I'm actually not gonna call home because that was way too harsh. And I don't know where that came from.
give it a
But
10.
please stop saying that.
so a maximum? how
Like
would
I
you
went
know
from
if it's
0
a
to 2,000. Okay.
How,
Caleb.
how would you know if it's a maximum?
Maximum is like a top, like upside down. Like right here. This one has a maximum. Like it's
So
the
if it's
top of a
upside
hill.
down, it's a maximum.
If it's right side up, it's minimum. Yep. Okay. I want to talk about some things with symmetry. If something has symmetry or not. So we have x minus 4 squared. So let's think this is going to move to the right. 1, 2, 3, 4. And then it's going to look like this. Oop. It's going to look like this. Okay? Does it have symmetry? Can I fold it in half and it be the same on both sides?
Yeah.
Yeah.
Yes. At where? When x equals 4. Right there. Let's try 5. Because we need to practice. Now, what's a cube root going to look like? Is it going to look like this U shape?
No, it's gonna look
Is it
like
going to look
S.
like just 1?
No.
Or is it going to look like 2? Yeah, I think look like an Egyptian too. That's what I think. Okay? All right. All right. So I'm going to move left 4. 1, 2, 3, 4. Okay? And I'm going to be like 1 and 1. Okay? And we can graph it just to double check. We should always double check this Murphy, right? That's what we learned in life. We're going to say the cube root of x plus 4. Yep.
So
All right. Does it have symmetry? Could I fold it in half anywhere?
No.
No.
So it'd be no.
I can't fold this in half. It would be the same. If I folded it in half, this would be down here and this would be up here. That's not right. I can't fold it this way because this doesn't go over here and this doesn't go over here, right? Yeah, but it's not symmetrical. Okay, now we're going to talk about end behavior. And end behavior is probably the most important thing we're going to go over. You're going to use it in Algebra 2 a bunch. Okay?
That's senior stuff.
All right. No, junior.
Oh.
Okay. All right. So, end behavior. And we've kind of already talked about this a little bit. We just didn't use the right vocabulary. End behavior describes what happens to the y ends of the graph, we could say, as x approaches infinity or negative infinity. This is what infinity looks like, negative infinity. Okay? So we're going to talk about all the rest of these. Okay? So, x squared plus negative x squared plus 6. So I know I move up 6. It's negative x squared, so that means it goes like this. Okay. So let's talk about end behavior. So as x goes towards positive infinity, what does y do?
Goes negative.
Yes. So let's talk about as x approaches negative infinity, what does y do? So this is negative infinity. What is y doing? Let's look. X is approaching negative infinity. It's getting smaller and smaller and smaller. What's y doing? So x is approaching. Negative infinity. As x approaches negative infinity, what's y doing?
Wait, will you explain?
Yeah. So, we're looking right here, all right? So as our x value gets bigger, as I move down the x-axis, right, I'm following my line, I'm going towards negative infinity, right? So as x goes towards bigger and bigger numbers, y gets smaller and smaller, okay? But if we look at the other side, as x gets smaller and smaller and smaller, what is y doing? Getting smaller and smaller and smaller. Do you see that? Because it's pointing down? Yeah. So if it's pointing down, it's going towards negative infinity. If it was pointing up, it'd be going towards positive infinity. And every once in a while, it goes towards a specific number. Okay? So, let's look at the next one. I suggest, because we might not, I remember exponentials, we didn't spend a lot of time graphing, or at least I felt like we did that really fast. So let's put that in our graph, in our calculator. We hit 1/3 to the x. I'm having a brain moment. I can't figure out how to do. How do I do an exponent? Hit control.
You don't have to click on
With the exponent.
it's that little arrow.
There we go. Thanks, guys. Sorry. And we look like this. Okay. So we cross 1. And we're going up, right? And this one's, it's like a Nike swish, right? All right. So, x approaches infinity, x approaches negative infinity. What does y do for each of them? Okay? So we always set it up something like that. Okay, so which one's going to be easier? Which one can you really see where it's headed? If x is approaching negative infinity, where am I going? Am I going up or down? As x approaches negative infinity, where am I going? Tell me, up or down? Up, and up is towards infinity. So as x gets smaller, y gets bigger.
Is that X getting bigger?
Okay. These numbers, this is towards negative, right? So negative 100 is smaller than negative 1, right? You want to owe less money kind of a thing? Okay. Now, as x gets bigger, what is it approaching? Yeah, like, y isn't going up. It's approaching what? 0. It doesn't dip below, right? Because we talked about this, right? If I cut this paper in half, I can always cut the half in half, right? If I cut that in half, I can always cut it in half again. Does it matter how small I go?
No.
Can I always cut it in half? All the way to molecules, right? Like cut an atom in half, right? Okay. And then cut that. If I can cut an atom in half, someday I should be able to cut the half in half, right? So it's approaching 0. It's never going to get there, but it's going to get really, really close. So let's do the next side.
Is that gonna be on the choice one?
End behavior is yes. All right. I have no idea what this says, so let's make it up. X squared plus 2x plus 1. Let's put that in our calculator. So we're going to put in our calculator x squared plus 2x plus 1. So, looks like this. Okay. So as x approaches approaches infinity, what is y approaching? So remember, I start right in my middle. So x gets bigger if I go to the right, correct? What's happening to y? Where is it going towards? Yes. If x is approaching negative infinity, where is y going? So I follow my line, and I'm going to go to the left, because that's where x gets smaller. Positive infinity.
Too much.
Okay. Okay. Let's move on to number 1 and 2, because these are questions like that you'll have on the quiz.
How many questions on
4.
Should that
Okay.
rule my test?
All right.
I
All right.
could fail it.
So we've got the exact same problem. So I don't think it was it, but at -3 I've got 4. At -2 I've got 1. At -1 I have 0. At 0 I have 1. At 1 I have 4. Just graphed it real quick. What is the domain? What could the x's be? All real numbers. Because there's no x that I couldn't plug into this equation and get an answer. What about the range? Y has to be greater than or equal to 0. What is this a minimum or a maximum?
The maximum.
Minimum.
Wait, minimum. No.
It has a bottom. Minimum.
The bottom is the
Okay. What is this bottom? What are the numbers?
1, 0.
Does it have a line of symmetry?
Yes. I got
Where?
it.
At -1, right? Right here, I could fold it in half. Okay. As x approaches infinity,
No.
y approaches, that's a -1, sorry. That's an arrow. No, I don't know why it's there.
X approaches infinity.
X equals
Because it
-1.
doesn't sound right.
As x approaches infinity, where's y going? Infinity.
Because it's
As
not-
x approaches negative infinity, where is y going? Infinity.
Oh, because on the left side it's like. Wait, why is
Okay.
Y approaching?
Why don't you guys try number 2?
Oh, because it's not going downwards.
So just put it in your graph. Put it in your calculator.
Is it just me or is it 50 sideways?
Yeah, I can't do it. I turn my paper sideways and just do it 80.
There you go. That works. Oh wait.
The Y is like what's in that space, right? Like Y is the greater of the center space.
Okay, I'm doing it. What's the domain?
Already.
All real. You can also do this. Okay. What's the range?
Y is less than or equal to.
Right here.
Oh.
Do the y one. You told me the x value at that point. Make sure to the y. Does this have a max or a min?
Max.
And it is negative 6, 2. Does it have a line of symmetry?
Yes.
At what? X equals negative 6. Okay, here's the end behavior stuff.
X goes to infinity, as y goes into negative,
Y goes to negative infinity. Good.
and then x goes to negative infinity, and then y goes
You got it.
Because if y goes downwards,
It's going negative infinity. If it goes up, positive infinity.
I mean, I got the
and as
bottom
x
one right,
goes,
but the top ones I put X is negative and Y is positive.
because if x
They're
goes
both going
x-
down. The Y's have to. Y's is which way it's facing. You always have X's. One's going positive, one's going negative. The Y's, down is negative infinity, up's positive infinity. Okay, we're going to take this sheet. We're going to turn, I'm literally going to do just a couple problems on here. And these are problems that are just like your quiz, is why I'm doing them. Open it up, turn to number 1.
Are all the questions on the quiz gonna be like this?
Which pack is that?
The other packet.
can we do it by yourself?
Okay. No. All right. I wish, but I want to make sure we have enough time. Okay. So we have x plus 7 minus 3. We know we went to the left 7, down 3. Okay. You can put this in your calculator if you want. Okay. It's going like this. Okay. All right. Does it have a min or max? Does it have a point where it stops at?
No.
Yeah, right here.
Oh, yeah.
Minimum.
Does it look like this?
So it's minimum.
No.
Then you put it in incorrect. Okay, so it does have a minimum. It stops right here. Its minimum is negative 7, negative 3. Domain, careful. What is x?
X is greater than or equal
Not negative 3,
to negative 7.
negative 7. What's the range? Y has to be greater than or equal to negative 3. Is it symmetric? No. Did it shift vertically, up or down?
Down.
It usually goes through here. This is what the original looks like.
Left and right, right? Or up
So-
and down, up and down. Right?
Up and down is vertical. So where did it go from here?
You went
This
down
went
three.
down 3.
Left
And it
seven.
went left 7. Okay, let's talk about end behaviors. X approaches infinity. X approaches negative infinity. Okay,
Wait, now why negative? It only goes one way.
then we can say it doesn't exist, right? Okay, so as x approaches infinity, y approaches what? Infinity. Does x approach negative infinity? No.
What's the difference between the bottom and the top?
This is infinity and this is negative infinity. This is to the right. Top is to the right. Bottom is to the left. Okay, let's do 2. Okay. Cube looks like a, I think of it as walk like the Egyptian. Okay? But I moved to the left 1, up 5. Okay. Does it have a min or max? No. What's the domain?
That's all.
All real numbers? What about the range?
Um,
This can keep going down. This can keep going up. It just goes slightly. It's all real as well. Is it symmetric?
No.
How did it shift vertically? It went up
Up 5.
horizontally. As x approaches positive infinity, excuse me, y approaches, y is going up, so infinity. As x approaches negative infinity, y approaches negative infinity, goes down. Because it's going down. Like, let's look at it. Hold on. I didn't even grab
The
it.
left side, it's going up, so it's being positive infinity, and the x is also going right, so it'll be positive infinity. But if the x is on the left side, it's going towards the negative numbers, so it'll be negative infinity, and the y is going down.
Hold on, Caleb. I'm not even listening to you. Hold on. Right. I didn't even hear that. Okay. So, do you see how this is going slightly down? And this is going slightly up? That's where it's going. If when we look at the left, it goes down, it's negative infinity. If when we look at the right, it goes up, it's positive infinity.
That's exactly what I said.
Okay.
How does that get to all the other
If y values is going up, when I go to the right, it's positive infinity. When I'm looking at x values and I go to the left, if it's going down, it's negative infinity. Okay, we're going to do we're going to do one back here. We're going to take out your other paper.
This?
Yeah.
So many people.
Are these gonna be due tomorrow?
I'm going to some stuff to do tomorrow, but I'll tell you what it is. Okay. One on here. We've got, it's upside down. We move to the right one, up 4. It's negative. Looks like this. We plotted those points, blah, 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 blah. Okay. What's the domain for this?
All real.
X is all real. What's the range?
Y is less than or equal to 4.
Is it a max or a min?
Max.
What's the point?
1.
Is it symmetric?
Yes.
At what?
1.
Did I vertically shift it?
Yes. And right.
Horizontal, right one.
What's that sign?
Yeah, it means all real numbers. Okay, we're going to move down to the very bottom, and then we'll be done. A and B, these are for every single problem you're going to have to do something like this. Okay, so here's a problem, x plus 1 minus 7 over these intervals. So all I'm going to do is make x and y. I'm going to plug in 3 and 8 into this equation. So I'm going to do square root 8 plus 1 minus 7 gives me negative 4.
Fine.
Thank you. I'm going to do the same thing but with 3.
You put a negative 8 for x.
So I put the
Or
square
negative
root
for x.
3 plus
Oh,
1, move it on the outside, minus 7.
Oh,
I get negative 5. Now I'm going to use this information with slope. So that's like y2 minus y1 over x2 minus x1.
Negative 5 minus
Negative 5 minus a negative 4
3 minus 8.
and a 3 minus 8. Yep. These become plus. I get negative 1 over negative 5, which is 1/5. That's my answer.
I did these wrong. It's because 8 is y2 over x2.
It doesn't matter.
Okay.
Okay, next we're going to do the same thing. Why don't you guys try B on your own? Yes, that's why I'm telling you to do it.
Why do you do 8?
Because it says 3 and 8 right there.
happens if I can't plug the -1 into
Doesn't matter. Okay. So when I plug in -1, I get -1 plus 1 is 0. What's the square root of 0? 0 minus 7 gives me -7.
So I got 1.
0 plus 1 is 1. The square root of 1 is 1. 1 minus 7 is -6. What are we doing, guys? Are we plugging it all in at once?
Yeah, we're plugging it all at once.
When I do it, I don't get that.
I did it.
So I said -1 plus 1
I can see what they did.
minus 7. Look, this is what we did. See how the negative, here. See the -7 underneath the square root sign? Can't be.
Let's be out of this.
Good afternoon, Lincoln High School.
Minus
This is
7.
Drew Boss with your afternoon
Make sure it's, don't make sure it's not underneath the square root sign.
announcement.
And then we should get -6 minus a -7 over 0 minus a -1. We get 1 over 1.
The applications are now available in the counseling office, and they are due back to us by June 1st.
So, okay, so this is homework